Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Joel, Seth's brother. We're here to hopefully help you approach SAT math questions and also approach studying for the Math SAT. A great way to study for the Math SAT is to get a College Board account. And Khan Academy has partnered with the College Board, and they list all 40 topics that are on the Math SAT, and of course the English also, and they give you 20 questions per topic. We are going through the highest levels of these questions. Sometimes we go through the lowest, but on most of these topics, we only do the top 5. And today we're doing the second of 5 of the top questions related to this topic, called isolating quantities. On the actual SAT, I'm not going to be told what the topic is for the question, but the best thing to do is get proficiency in all of these topics that you sort of don't have a choice, because when you sign up, they put you in the first question. You have to go through all 20 to get to the top level. Okay, without any further ado, please try this problem, pause the video, and come back, and we will try to do it. Okay, it is of course, isolating quantities. For the equation above, which of the following correctly expresses x in terms of a and y? In other words, solve for x. And this is typically known as a literal in your normal curriculum in school, and most people call it a literal. And this is it. You have to solve for x, right? So you have to get x by itself. So you have to do everything you can to isolate that x. So you first look at the x term. You got to get the x term by itself. So you write 18 minus 5y. That blows off that. Then you got to get this a away from it. So then you divide both sides by a.
Oh, wait, hold on.
Okay, what's that? Yep, what's up?
Okay, good. Excellent. Yeah,
Right?
you notice you changed the sign of the 5y and the 18.
Yes,
Because
yes,
you brought it
yes.
on the other side of the equal sign.
I hope
Yeah.
I'm not going too fast. Yes, and
Yeah.
minus 5y. Here I showed more work. Now there's a nice parentheses. I overdose on parentheses. I don't know about you. Do you overdose on parentheses?
Yeah.
Yeah, overdose on parentheses. Now you got to solve for x. This is a little tricky. First you have to subtract 1. So I'll just do that, okay? And this becomes a 0. Now you got a negative x, but they want you to solve for x. So this negative x is being bothered by being multiplied by negative 1. So you can either multiply both sides by negative 1 or divide both sides by negative 1. Seth, should we multiply both sides by negative 1 or should we divide both sides by
I
negative 1?
would just change the sign of everything on each side.
Yeah, but we have to justify everything if we can.
And multiply it.
Okay, fine. So we change the sign on both sides of the equation, which is essentially multiplying and divided by negative 1. And then we look at the answer. This one is not over the a, okay? Ooh, be careful. Well, none of them have that anyway, right? None of them have 1 divided by a. So now you got to really be careful here. Oh, boy. And they knock the parentheses out. So negative sign city here, right? So we got to be very neat here. Wow, do you have to be careful? Plus 5y. This is where you slow down and you make sure everything's right. Wow. And this, by the negative sign, it implies the parentheses, doesn't it?
Yeah.
Wow, so you actually did not have to multiply the parentheses. So this is really x is equal to 1 minus 18 minus 5y divided by a. Hopefully that's one of the answers. Yeah, it is. It's a, isn't it?
Yeah.
Yeah, it's a. This is one of the, I don't know about you, so you give advice. But for me, slow down on this one. Slow down. Too many negative signs. This is the one where you want to invest an extra 20, 30 seconds. You could at some point do some analysis. Let's see what's unique. This is a plus 5y. This is a minus 5y. This is a minus 5y. And this is a plus 5y. So you can't just say, well, what's the sign of the 5y? There's a plus minus 1s here, plus minus 1s here. I don't know. What do you think?
Yeah. Well, I checked it. I checked it in 2 steps.
Okay.
One step, I'll be using red, is that in the original expression, but the 5y and the 18 occur as a difference.
Okay.
So this is one input. This is one expression that expresses some value that is given and which we're going to use in expressing x. So 5y and 18 are going to stay together in a subtraction.
Smart.
And therefore,
Smart.
that indicates that
Smart.
this is the only one in which 18 and 5y stay together in a subtraction,
Well,
except, of course, for this one.
of course.
Now,
Right.
the 1 minus x, when I solve for x, I'm going to end up with x equals 1 plus or minus some other junk. So it's going to be x equals a 1, and therefore it's not going to be this, because this is x equals some junk minus a 1, x equals minus 1 plus some junk. So that rules out these two, and therefore I check that A is correct. But I would recommend doing an analysis like that to check your work after you've done the elimination that Joel did illustrated in black.
So you would not suggest doing the problem the way you did it to actually choose which answer?
That's the way I did the problem when I first saw it. But I've been doing mathematics for 40 years, 40, 50 years, 60 years. So I would recommend that if you're SAT takers, be a bit more careful. And then use this observation as a test to check their answer.
Okay.
But the thing is, when you were checking it, I didn't hear a very clear explanation of what you were checking. It sounded like you were just redoing what you did before.
That's right. I was proofreading every line.
Okay, so that's a help. It's it helps when you check something to check it a different way from how you originally did it.
Absolutely. Well,
when you originally did it, you made a mistake.
That's right.
And then when you proofread it, you make the same mistake.
Yeah.
And you never find it.
That's right. That's why it's really hard to get hundreds on all tests.
Yeah.
But that was true. Do you notice in the Friday's video, I did the problem and then I did it another way, and that's how I caught the mistake I made in the actual thing. Yeah, the first way of doing it. Yeah. If you could do a problem two different ways, that's great. And if you have the time to do it, it doesn't take that long to do what Seth did. But the question is whether you have the time on the test. But that's great. And you could also do it the way Seth did it for real and not just use that approach.
Yep.
Okay. This is called the literal. It's pretty standard. So they really are.
Yeah.
There are at least two ways to do it, and I think we went over the two most obvious ways. There are probably some other ways.
Yeah, there's a way that is helpful when you're doing problems like this in a genuine application of math to science. In the real applications that you see in advanced courses, and when you actually become a scientist, the equations are much, 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 much more complicated than these little baby equations.
I think I know what you're going to say. Can I take a guess?
Yes.
I guess, and this is another way to check this, but it's not practical right now. Let A be 2. Let X be 4.
No, 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 no.
let y be
Okay,
7. No,
that's an idea. Yeah,
say,
check it like that. Okay, check it like that.
put numbers
But
in for these, and then calculate this, calculate this, calculate this, calculate this one, calculate this one, calculate this one. But you're not going to use 4 and 7.
no,
You're going to
I'm talking about a situation where the formula, may have 50 symbols.
yeah.
What would you do?
Well, let me just mention one thing, because this people may not realize you could do this. If you're checking anything in math, if you're checking any type of equation in school or whatever, you could just make up numbers. A is 2, x is 1, y is 3, and just literally plug it in, and whichever one matches, it matches. You'll never get it right because there's so much algebra anyway. But theoretically, this is a good
Never
way.
get it right. That's cynical.
No, well, you're going to make a lot of stupid mistakes if you do this. If you're doing this, you got to do this 5 times. So, but it will work, right? It will work. But most people don't recognize that.
Not if you make mistakes, or not if you're guaranteed to make a mistake.
That's true. But theoretically, this can be done. You make up numbers, you plug it in, whichever one works.
Well, nowadays, plenty of computer systems are available to do algebra for you.
Well, yes. In fact, calculators and everything, websites, of course, yeah. Okay, I'm dying till I may have other thoughts, but I don't want to waste everyone's time. So what is it, Seth? I give up.
My idea is
I give up.
I know. Let's see. Here's where can I get a clean spot?
Could we just
could you isolate?
I'll tell you what. How about could we clear everything? Does that help?
Yeah, clear everything.
Okay, here we go.
Clear everything.
Out of here. Clear everything. New idea. Let's see the fourth approach to this thing.
Yeah.
And it's a good idea to sit here and come up with just the idea of thinking about different approaches.
This is what you would do if, like, instead of this 18 being an 18, this 18 were a humongous formula of 25 symbols.
Okay.
This is what I would do. I would write, I want to solve for x.
Right.
Right. X is the goal. So x is the goal. Little x is the goal.
Fine.
Little x is the goal. So I write big X equals 1 minus x. Okay. And then the answer is little x equals, what is it? Little x equals 1 minus big X. Right. Now I have to find big X. So the equation has become A times big X minus 5y.
Well, it's plus minus 5y. It's 5. Oh, I see what you're doing.
So plus, right? No. Let me get it right. Let me not make a mistake. Let's not make a mistake here. Yeah. Okay. So I've converted this equation into A times big X plus 5y minus 18 equals 0. Now pretend the 5y minus 18 is a huge, ugly formula.
Okay.
So what I'm going to do is isolate it by putting it in parentheses and call it y.
Okay.
So what I might write on the side is y equals 5 big Y, 5 times little y minus 18.
Okay.
And then I've converted the equation to A times big X plus y equals 0.
Okay.
Now it's a much simpler equation, and so I'll solve for the big X. The big X is equal to what? Minus y divided by A.
That looks very nice.
Now, and then to get the final answer, I substitute the value of y, the value of big Y for the y here, and I get x. I get some messy thing, and then I substitute that value into the x here. I take whatever junk I get here, I subtract it from 1, and that's the answer.
Right, so you carry everything whole, big chunks.
Well, what you do is you create new big symbols that are symbols for junk that is a lot bigger. So and then you work with with your invented symbols to solve the simpler problem. And when you're done, you have the answer in terms of your invented symbols, and then you replace them with their values.
Right. So you don't have to. So I know you don't have to write the 25-term thing 75 times, because you don't have to move it this way and that way and change its sign and do all this crazy stuff.
Yeah. Wow. And then this method is particularly helpful, is also helpful when you want to say either do the solution or check the calculations on a computer. Because in the computer, you could program that it will, calculate y, calculate big Y from that complicated expression involving the little y, and it could calculate the x from the big Y, and they could calculate the little x from the big X.
So you're just talking about three little instructions for the computer.
Yes, you could program to program this stuff.
So you've got a few definitions.
So for programming it.
Yeah. Right, so you got a few definitions and only 3 steps.
Only three for programming it,
right.
For programming it, you would write y, and then programming we use an assignment statement. Y is gotten the value from 5y minus 18.
That's right.
And then we calculate x.
Big X.
It's gotten from big X. Yes, big X is gotten from the value minus y divided by a. And then
little x.
You want to solve for little x, and so you write little x. There you do the easy solution by hand. The easy solution by hand is written as little x equals 1 minus big X.
Wow.
So here the computer, and then somehow y and little y is an input data. Input is what's in terms of a and y. A and y are inputs. So in the computer programming, what you might have there is what you might have in a program is what happened there. I can't erase your junk.
I don't think I wrote much junk here. You're the one writing junk. I'm in black. See?
Yeah. So what what would happen is, you would get A would be input.
Right. Yeah.
And we say read A, and then Y, little y would come from the input.
Right.
Some input operation.
Cool. So
or you might just type in the numbers, just the number thing.
Nice.
And then, of course, to get the answer, you give it the print commands.
Right. Yeah, very nice. Wow, cool.
Text.
Yeah. So I'm pretty sure it's coincidence. I just want to make sure. Is there a reason why you had a solid dot here and an open dot there? That was just coincidence.
No.
That's coincidence, right?
No, it's I meant 2 dots. 2 solid dots.
Okay. I was just curious because I know with inequalities.
No.
Okay, fine. It was a cool way of saying something. Okay.
It's a cool way of saying this is a so-called assignment or variable setting operation in programming
Right.
not an equal sign as in equations in mathematics.
Got it. I know last week you were
And
getting on that.
most programming languages actually use the equal sign
Right. Yeah. Yeah.
for setting, so if you say y is set to 9,
Right.
print y, it's going to print a 9.
Right.
And
Yeah.
then
You're
you
just
say
telling.
y is set to 3, and then you say print y again. This time it prints a 3.
Right. Yes. Okay. I guess
Whereas
that.
in mathematics, if you say y is equal to 9, and then you say y equals to 3, then with your second statement is you could make statements in mathematics, but they might be wrong, false.
Mm, yeah.
X equals y and x and y equals 9 and y equals 3 cannot be both true. But
Right.
in programming, when you write y is assigned to 9, it makes y take the value 9. And then you do another assignment statement, assign y to 3. It rubs out the old value of y of 9 and changes it to 3.
Right. Yes. Okay. Very important subtlety.
Yeah, of
Yeah.
course,
And
the
understanding.
modern, however, a new thing in our generation is functional programming, where you can only assign a variable once.
Mm, wow. Okay. Well, that's not our generation. That's the new generation.
Well, some people our generation
Yeah.
do it.
Some people. Right. Yeah. 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 Wow. We've really done it on this one. Okay.
Yeah,
So
we
I
did
guess
it.
that's it. Wow. Okay. This is a really good explanation about some basic programming and also the idea of variables. It's so important, and this is the key to a lot of programming is the variable assignment and dealing with that. Very smart way of doing it, and organizing the information. Very smart way of organizing information in packages. Okay, so have
Well,
a great.
didn't you do calculations like that in engineering?
I'm sure. Yeah, I'm sure. Of course. Of course. Of course. Yeah. Yeah. You always break big things up and just say, well, what's the.
And engineering, your equations are your expressions are really big, aren't they?
Yeah, but the actual like formulas, if you go through an engineering book, you may see a massive, you may see a really simple formula with a big A in it, right? A big A, well, really big A in the formula. But the big A could be made up of 30 terms, but you carry
Yeah.
it as an A. So that it
Mhm.
looks like the equation is easy, but really underneath it, this A is made up of a humongous number of terms. So, okay, I think we're done. So have a great day, everyone. Please like us, dislike us, give us comments on our YouTube channel, SAT Math Question at gmail.com. And if you have any math SAT questions, feel free to email them to us at our email address at SAT Math Question of the Day at gmail.com. Okay, everyone, have a great day, everyone.